My name is Nicolas.
I'm Chase.
I'm Brandon.
My name is Alex.
And my name is Victor. The title of our project is Process and Layout Improvement at Karat Packaging. We carried out the project at Karat Packaging, which is located at Chino Hills. So Karat Packaging is a supplier and manufacturer of premium beverage and food service products. They primarily manufacture disposable plastic paper, food, and beverage containers. For the overview on this project, we'll be focusing on four major areas, which are facility layout, machine downtime, safety procedures taken in the facility, and quality control. Now I'm going to be handing over to Nick to talk about facility layout.
Thank you, Victor. We will now begin with the facility layout. In order to determine how much different machines and departments interact with each other, we used an activity relationship diagram. It is a means of displaying the closest rating among all the activities or departments in a facility. As you can see, there are 6 ratings in total, starting from absolutely necessary to undesirable. We also have our reason codes. It might be a little hard to see the diagram, so I'll highlight one of the relationships. The extruder makes these large plastic rolls made from polypropylene terephthalate or PBT chips. The lid and plastic cup machines are dependent on that material to make the lids and cups. That is why these machines have an A rating. We have the current layout on the left and the alternatives on the right. The Karat Packaging has 2 areas of production, consisting of plastic and paper. Paper has its own department, signified by the pink box. Plastic production is dispersed throughout the facility and consists of these machines: plastic cups, which are green; lids, which are red; takeout container and sauce cup, which is blue; and finally the extruder, which is black. The goals for these alternatives were to implement staging areas that reduce the distances traveled by their employees on forklifts, and reduce the number of staging areas or consolidate most of their staging areas into one centralized area. With alternative layout 1, the goal was to group processes that have similar inputs. Therefore, we swapped the lids machine, which is green, with the takeout container and sauce cup machines, which is blue. To do this, we use something called group technology. It is a technique in which similar manufacturing processes are grouped together. Our reasoning is that the takeout container, sauce cup, and extruder machines require the same inputs, which are those bags filled with PBT chips. With alternative 2, we removed the large extruder because we learned from Karat's technicians that it was possible to retrofit mini extruders to each of the different machines in plastic production. Using the data that we collected, one of the lid machines that they have currently was hardly running because they would move those operators to the plastic cup machines because those would make them the most profit. With this in mind, we decided to remove that lid machine and have its workers placed onto other different machines. This is what the flow currently looks like in the facility and what the flows will look like in the alternatives. As you can see, the flow from all alternatives is less cluttered and the processes do not intersect as much. To do our analysis, we use ProMol to simulate the distances traveled by the forklifts and operators. I apologize for the weird naming convention that was used. Between the forklift bag mover, which transports these PPT bags I mentioned earlier, and the forklift pallet mover, which are essentially the same type of forklift, the forklift bag mover traveled the most distance at 143,000 feet. The other forklifts and operators, as you can see, barely reach 10,000 feet. So which alternative do we recommend? Well, both alternatives reduce the distances traveled by 40%, and because the pallet mover travels less than the bag mover, we decided to remove it. The cost of implementation for alternative 1 will be $69,000, with an estimated savings of $167,000 after 5 years. For alternative 2, the large extruder along with one of the lid machines will be sold, giving us a salvage value of $720,000. The cost of implementation for alternative 2 will be $223,000, with an estimated savings of $723,000 after 5 years. Therefore, we recommend Karat Packaging should go with alternative 2. Next is machine downtime, and I'll turn it over to Chase.
Thank you, Nick. Alright, so machine downtime was one of the biggest problems we identified in the facility. It seemed like every time we visited, there was a new machine down. We were informed that some machines are not operating at times due to a lack of machine operators, but the company wanted us to focus primarily on downtime caused by machine issues. It is also important to note that the company does not currently have any type of preventative maintenance schedule in place. We received data that summarized their daily production for about 60 shifts, and this data included how long the machines were down each shift, as well as the reasons why. Using this data, we first wanted to identify which machine was experiencing the most downtime. Next, we wanted to determine the greatest contributing factors, and then use this data to develop a preventative maintenance schedule in order to minimize the downtime. So the first step was to go through the data and sum up all of the minutes each machine was down due to machine issues, and it was easy to see that the plastic cups machine, machine 202, had the most downtime. This also worked out well because the company informed us that they make more money on their cups rather than their lids. The next step was to analyze the data and see which reasons were contributing the most to the downtime. In this chart, you can see that the greatest contributing factor had to do with grinder issues, followed by sleeve machine issues and motor cooling issues. Grinder issues were the cause of about 2,900 minutes. The sleeve machine was about 2,000 minutes, and motor cooling issues were about 1,400 minutes. Our next step was to use this data to develop a preventative maintenance schedule. As you can see, each problem is defined and explained in each row. In the procedure column, instructions are given as to how the issue should be addressed by the person performing the maintenance, and in the frequency column, estimates have been given as to how often each procedure should be performed based on the chart in the previous slide. We did not have enough data to calculate a precise frequency, so we have developed a check sheet that the facility could use to log and track the frequency of these issues. So right here is our check sheet. Each column represents a month, and each box should be filled out with how many times each of these issues occur monthly. Using this check sheet, the company will be able to determine how often these issues should be addressed when performing preventative maintenance. So here we have the economic analysis of our machine downtime recommendations. We assumed a tax rate of return to be 15%, and also assumed that the implementation of preventative maintenance would reduce the downtime by 75%. As you can see, the cost of implementation sums up to be about $10,000 each year, while the annual profit being generated is about $250,000. Over the course of 5 years, this would increase the company's profit by roughly $1.7 million. Now I'm going to hand it off to Brandon to discuss safety.
Thank you, Chase. So, safety can be overlooked in many industries due to the fact that it does not happen frequently. But due to regulations, OSHA monitors the safety of many companies so that they can reduce the potential health and safety hazards of many. At the facility, we talked to the safety manager and he mentioned that lacerations and back injuries are their most common injuries. Lacerations are usually self-inflicted when workers become careless opening boxes and leaving the blades exposed. Back injuries occur due to improper lifting techniques many of these workers have when working an 8-hour shift. The fact that they execute these techniques improperly can lead to a chronic health problem and become a severe injury. In addition, we've noticed that there weren't designated pathways for pedestrians to walk on. This can cause collisions between forklift drivers and workers when approaching a blind spot. What we wanted to do to reduce the lacerations was to implement a higher quality box cutter to improve the safety features of a tool like the one pictured on the right. This has a protective cover to prevent lacerations and only fit boxes in between the crevice. For back injuries, we want to implement a mandatory lifting technique class to allow workers to properly lift heavier objects by maximizing the use of their legs. In this slide, we've created a handout that uses cartoons we found online and added instructional steps on how to lift. We also want to implement this handout by posting it throughout the facility, especially at the staging areas. In addition, we will have mandatory training for new employees and evaluate each worker every 3 months to ensure that they are practicing proper technique. Lastly, we want to establish designated pathways for forklift drivers and pedestrians to prevent collisions. As you can see in these photos, the red dots represent a blind spot from an office onto a forklift path. By creating caution pathways, it will allow for pedestrians to be more aware of their surroundings before approaching the pathway. And in our safety economic analysis, workers are usually compensated about 2/3 of their salary depending on the severity of the injury. With our data below, we've based these calculations off of about 5 employees per year. For lacerations, it would cost about $20 per box cutter with a safety guard, which can save up to $480,000 a year, $824 for proper training to save another $384,000, and $93 for designated pathways to save up to 13,000 violations and $491,000 a year. So with these little investments, we can save the company significantly more by improving safety. And now I will hand it off to Alex for quality control.
Thank you, Brandon. Over the course of this project, and after visiting the facility, we found that Karat has a relaxed attitude towards quality control. Looking at the current paper cup specification sheet, we found that many of the tolerances are missing, and as of now, they tend to pass all orders even if they are not within tolerance. I mention this now because it will come up later. With that being said, we then gathered all data for machines in the paper department relating to dimensional tolerances. However, for the sake of time, only the OD for machines 301 and 308 will be looked at today. After gathering data, control charts were generated. The results showed that the process is out of control as seen at points 1 and 4 in the sample range chart. Furthermore, looking at the process capability graph, we can see that the machines are not currently capable of producing the cups with the current dimensions. Similarly, looking at the control charts for machine 308, you can see multiple points fall out of the upper and lower control limits, and just like machine 301, it is not capable of making the cups with the tolerances desired. In doing this analysis, we were able to establish the control limits shown. However, if Karat wants to establish new control limits in the future, further analysis will need to be done in order to find the reason for the instability of the machines. Moreover, it is important to note that the tolerances in red are larger than the original tolerances. Nevertheless, it should be possible to make these changes as Karat provides tolerances to the customers and not vice versa. Plugging in these new tolerances back into the process capability report, we can see that the PPK is at an acceptable level for both machines 301 and 308. If implemented, this change would significantly lower the scrap rate, resulting in about a $4 million profit over the course of 5 years for machine 301 alone. This is assuming Karat scraps all cups that do not meet tolerance limits. If we were to assume that Karat does not scrap their out-of-spec product, but sells it at a 50% discount, the profit would be closer to $2 million over the course of 5 years. However, it is important to note that scrap rates used for the current state is not entirely accurate, as Karat often allows out-of-spec products to pass as mentioned before. With that being said, I will now pass it off to Victor to go over the conclusion.
Now being able to go through the projects, let's take a look on the progress we've made so far. In improving the facility layout, we generated 2 alternative measures, and based on our findings, alternative 2 turned out to be better since it generated higher savings over the course of 5 years, saving them about $723,000. In reducing machine downtime, we generated a preventative maintenance schedule and thereby saving them $250,000 annually, which is about $1.7 million in the space of 5 years. For safety, we recommended the use of safety car and pedestrian walkway. We also recommended that proper lifting training be made mandatory for all employees. So, in the space of 5 years, estimated savings is about $1.3 million. For quality control, we recommended specification limits and established control limits. We updated the process capability which we indicated with the graphical representation. We also established current control limits and need to collect more data to establish assignable cause. From the economic analysis, we saved about $3.7 million in the space of 5 years. So, the grand total estimate saved for Karat Packaging will be summed up to $7.4 million. We can now take questions.